Hey y'all! So today we are looking into this thing called stoichiometry. What is that? Yeah, it's actually very simple. All it is if I give you a certain amount of reactant, can you tell me or calculate for me how much product are you gonna get? It's very easy. All you have to do is make sure you follow the necessary step and understand mole ratio. Oh yeah, mole ratio is the key to be successful in stoichiometry. So let's take a look at some examples. I'm sure that's something that you guys are probably, looking forward to. All right, so let's take a look at an example. So what I have here is, let's say, sodium reacting with oxygen gas to give you sodium. Well, that's sodium oxide. Oh, all right. Hey, first things first, man. Let's balance this reaction. I mean, it's not complete if this reaction is not balanced. And let me just reiterate exactly what this means. Okay, this is actually very important. This means for this reaction to go to completion, you need 4 moles of sodium reacting with 1 mole of oxygen to produce 2 moles of sodium oxide. That's what this means. That's the reason why we balance chemical reaction. Because if they're not balanced, you're not going to get this mole ratio of 4 to 1 to 2. Because it'll be messed up. We'll see that later. Okay? So, what is this all about? Well, let's do some, questions. So let's say I have 1 grams of sodium. And I want to know how many, let's say, mole of sodium oxide am I going to produce if O2 was said to be limited, or in this case, unlimited. Access. An unlimited supply of, let's just say. So, that's a good thing. Okay, this is a good idea to start with because we don't really need to take this into account. But later on, we're gonna have to take that into account later on. Okay, because hey, really no such thing as unlimited. Everything has a limit. But right now, we're just gonna say this is unlimited. You have an unlimited supply of oxygen gas. So if you have 1 grams of sodium, how many moles of this am I gonna produce? I guess this is a pretty fair question. Okay, so let's start. So, part 1. First, you're going to have to convert this into mole. That's right. Okay, we really can't work with 1 grams of sodium as of yet. We need to make sure that 1 gram of sodium is converted to the amount of mole of sodium. So let's quickly do that. Okay, so 1 gram of sodium. Okay, to change that to mole, we divide by the molar mass. Round it to the nearest 1, because that's the way I like it. So, grams cancel, and what you have here is 0.04 moles of sodium. Okay? Hey, that's 1 step closer to the answer. The second step is what I call mole ratio step. So if the mole ratio of Na and Na2O is 4 to 2, or in this case 2 to 1, if you have 0.04 moles of sodium, how many moles of this are you going to get? That's pretty easy if you think about it. So let's do this, Factor-Levels method style. So you have 0.04 mole of Na. And you're going to multiply that by a fraction. And in this fraction, you're going to put in the information where moles of Na cancels out, and what you have at the end is mole of Na2O, which is what you want. The only thing is, what number are you going to put? Well, that's the whole purpose of balancing these things, right? And balancing them right. So on top, on the numerator, you're going to put 4 moles of sodium. Because 4 moles of sodium right here will produce 2 moles of sodium oxide. So you put 2 moles of sodium oxide. Hey, I think I... I knew that was going to happen. I want to put 4 moles of sodium down here. I hope you know why. And then 2 moles of sodium oxide up here. By doing that, moles and moles cancel. Sodium and sodium cancel. And look what we have here. We actually have mole of sodium oxide, which is exactly what we are looking for. Hey, this is nothing more than 0.04 divided by 2. That's what it is. Okay, so the answer to this is 0.02 mole of sodium oxide. There you go. So let's do a therefore statement. Okay, just saying the great therefore statement that for 1 gram of sodium, you will produce 0.02 moles of sodium oxide. And that is dependent, of course, that O2 is unlimited. Because we will see later on what happens when this is not unlimited. Yeah, in the next lesson, we're going to see that, and that's going to drive you crazy, right? So hopefully you understand how that works, because this is actually what stoichiometry is all about. So let's do more examples. So therefore, we get really good at this. Let's erase all of this, and let's change some numbers. Let's change this number. Let's say I started off with 2.8 moles of this, and I want to know, I don't know, what's the mass of this? And that's pretty fun, right? Okay, so I have 2.8 moles of sodium, and I want to know how many grams of this am I going to produce? Okay, hey, let's go. So let's start with 2.8 moles of sodium. So remember, right off the bat right here, you can go and do mole ratio. You can do mole ratio. That for every 4 moles of Na, you're going to produce 2 moles of Na2O. Moles cancel, Na cancel, and what you have here is mole of Na2O. Well, I don't want moles of Na2O. I want grams of Na2O, so I'm going to have to change this into mass. All right, I'm not going to put no equal sign. You guys, we are good at this. I hope we are good at this. We're going to continue. We're going to continue changing moles to gram by multiplying by molar mass of Na2O. So what would that be? Okay, what I do know is that for every mole of Na2O, okay, it is, let me just quickly calculate that here on the side, 62 grams of Na2O. Okay, moles and moles cancel, Na2O cancel, so you're left, of course, here with mass of Na2O, which is a goal, exactly what you want. So, what would this be? So 2.8 divided by 2 times 62, that is going to give you 86.8 grams. So, again, in a concluding statement, 2.8 moles of Na will produce 86.8 grams of product. Pretty sick, huh? Let's do another one. What should we do now? Let's say I have 0.4 grams of sodium, and I want to know how many grams of this are you going to produce? Now, this is a little bit more real because most cases when we're doing some sort of chemical work, we measure these things in mass. And whenever we get product, we measure them in mass too. So if I give you 0.4 grams of sodium and ask you to react it with oxygen, okay, all you have to do is really just burn it. How much Na2O are you going to get by mass? So let's do this. So first things first, you need mole. You need to know how many moles this is, right? If you don't know what's going on in any question, the first thing you should do is change it to moles. That usually works. So 0.4 grams of Na. You're going to change that to moles, which is, of course, dividing it by the molar mass. Okay? Because that way, grams and grams can cancel. So what you have here is mole of sodium. Well, you're not going to stop there. You don't want moles of sodium. If anything, you probably want moles of sodium oxide. So let's do that. Let's do the second part, which is the mole ratio part. Okay? For every 4 moles of sodium, you will produce 2 moles of sodium oxide. So moles and moles will cancel. Sodium and sodium will cancel. And what you have here is mole of sodium oxide. I don't want mole of sodium oxide. Mole of sodium oxide doesn't say much to me. I want grams of sodium oxide. Now, can I change mole to grams? Absolutely. That will be for every mole. Okay? I'm going to have to calculate this again. 62. That's right. 62 grams. Here, moles and moles cancel. And there you go. Okay, what you have here is mass of Na2O, which is exactly what I want. So let's put these information into my calculator. Divided by 23, and then divided by 2, and then times 62. And my answer is 0.54 grams of sodium oxide. Okay? So 0.4 of these can produce 0.54 of these. Now, if I was going to ask you a question and say, hey, knowing the fact that you have 0.4 of this and you will produce 0.54 of these, how much of these did you use? Well, under the law of conservation of mass, the sum of the reactants equals to the sum of products, right? So if I know that this is 0.4 and this is 0.54, hey, this is really just 0.54 minus 0.4, right? Pretty simple, right? Because of law of conservation of mass, this is really just 0.14. Because 0.4 plus 0.14 is going to give you 0.54. So you use 0.14 grams of oxygen to make this all happen. Okay? So hopefully you guys are getting a grasp of this. This is really not that hard. It sounds scary, you know? Stoichiometry, you know, what is that? But once you know how to do some of these things, they're pretty simple. All right, let's do another one. Let's really get good at this and do some more. Yeah, let's take this away. All right, what can I do here? Okay, let's put a little spice into this. So let's say I have 2.8 grams of sodium, and I want to find out how much of this am I gonna make. We did some mass, we did some moles. How about do some molecules? You guys would love this, wouldn't you? Right? How much molecules of this are you gonna have? So, hey, let's do this. That's not that bad. That's not bad at all. So again, change that to moles. let me just put in the chemicals here. 2.8 grams of sodium times 1 mole over 23 grams. So it seems so repetitive. We always start with changing it to moles. Unless it was the other example where I gave you this in moles already, then you don't have to change. Yeah, to moles because it's already moles. But then whenever I give you this in mass, change it to moles because only when this is in moles, you can start relating mole ratio. Like 4 moles of Na produces 2 moles of Na2O. By doing that, Na cancel, moles cancel. Here you go, moles of Na2O. What are we going to do here? Because I don't want moles of Na2O. I want molecules of Na2O. Molecule. Do you remember how to change moles to molecule? I hope you do. It involves this dude that sounds like a fruit. That's right. You multiply by Avogadro's number. Because Avogadro's number says for every mole is equal to 6.02 times 10 to the power of 23 molecules. I hope you remember that. Put this all together and you'll find out exactly how many molecules of Na2O you'll produce. So let me do that on my calculator. So 2.8 divided by 23 divided by 2, and then times 6.02 times 10 to the power of 23. And my answer is 3.66 times 10 to the power of 22 molecules of Na2O. Oh, I forgot to cancel these. There you go. There you go. So 2.8 grams of sodium, okay, produces that many molecules of product. Again, assuming that this is unlimited. So as you can see, there are many possibilities in terms of what I can give you and what I want from you. Okay, I can give you this in molecules too. Oh yeah, I can give you this in molecule. Can you tell me how many molecules of this you're going to produce? Or I can give you this in molecule and ask you, hey, how much mass are you going to produce of this? Or I can give you the same thing, 2.8 grams of sodium, and ask you, hey, how many sodium atom are you going to produce? And that's not hard, right? Not hard. It's really just adding a little bit more math, and you'll be all good. So hopefully you sort of understand exactly how this works. So let me do one more before you go ahead and do some more questions on your own. Okay? This one is a little bit different, but it's really not this. It's really the same thing. So I have 2.5 grams of this. Okay? And I want to know how much of this am I going to need for the reaction to go to completion. I want this reaction to go to completion. I want to know if I have 2.5 grams of sodium, how much of oxygen do I need at least for this reaction to proceed to completion? Sounds like a difficult question, right? Sounds very different. Before we have, I give you this amount of reactants, how much product am I going to get? This time I said, here's one of the reactant. How much of the other reactant are you going to need at least? It's a different question. But the operation of this question or the process of finding the solution is really the same thing. It's all about mole ratio. This time the ratio is 4:1. Let's do this, man. Let's do this. So 2.5 grams of Na. Again, change it to moles. Right? That way, you have mole of Na. This time, you're going to relate the mole ratio of Na and oxygen gas. So it's 4:1. What that means is that For every 4 moles of Na, you need 1 mole of O2. See how I set that up? Moles and moles cancel. Na and Na cancel. And what I have here is moles of O2. Right? I don't want moles of O2. My question says I want mass of O2. Yeah, I can easily do that. Okay, because I know for O2, for every mole of this is 32 grams. Right? That's the molar mass of oxygen gas, 16 times 2. And what's the answer? So that's 2.5 divided by 23 divided by 4 times 32. Hey, there you go. There you go. Rounded to the nearest, I guess, 100th. No, that's not rounded to the nearest 100th. This is rounded to the nearest 100th. So there's your answer. Let me not forget to scratch that out. So what does this mean? This means that for every 2.5 grams of sodium, you need at least 0.87 grams of oxygen. Because if you don't have enough of this, this reaction will not go to completion. If you have too much of this, if you have over 0.87, that's okay. That just means that O2 is in excess. Wow. This will set up my next lesson. Limited and excess reagent. Oh, man, I'm going to look forward to that one, huh? All right, let's do one more, and then I think you guys are all good. Oh, my goodness. All right, let's do one more. Let's do one more. This time, I say I wanted 4 grams of this. Oh, yeah, I want 4 grams of product. I want exactly 4 grams of product. Based on the fact that this is unlimited. Why did I say limited? Based on the fact that this is unlimited, how much sodium do I need to accomplish this task? Yeah, some dude says, hey, I want 4 grams of sodium oxide. Exactly 4 grams. How are you going to do that for me? Okay? Well, the idea is the same thing. Right? Same thing. So let's do this. I have 4 grams. I need 4 grams of sodium oxide. Okay? Let's change that to moles. For every mole, okay, I can't believe I already forgot what that thing is. Oh, yeah, 62. 62 grams. So grams and grams cancel. So now I have mole of sodium oxide. Well, for every 2 moles of sodium oxide, I need 4 moles of sodium. See how important it is to know how to balance these things well? Because if you don't balance things well, or if you don't know how to balance, man, you're not going to get these numbers. If you don't get these numbers, man, everything's out the window. Man, it's cold out there too. Moles and moles cancel. Na2O and Na2O cancel. So now you have moles of Na. I don't want moles of Na. I want mass of Na. I need to know how much I should put on my analytical balance. There's really no such thing as a mole balance. I wish they have. That's really, but that would be kind of ridiculous if you think about it. All right. Hey, that's not hard to do. All you have to do is for every mole is 23 grams. So moles and moles cancel. And by doing the math, 4 divided by 62 times 2 for 4 divided by 62 times 2 times 23 is 2.97 grams of Na. So if my boss wants me to make 4 grams of Na2O, well, I'm going to need at least 2.97 grams of sodium to make that happen. Okay? Of course, assuming that O2 is unlimited. Because in the next lesson, that's not going to be limited. It's going to be a number, and what do we do then? Anyway, I hope you guys are okay with this one. See you in the next chapter. Lates, man, lates.